Welcome back to All This Math. This is Professor Parker. And since you're here, go ahead and hit the like button. Go ahead, hit the like button. All right. If you're not already subscribed to the channel, please subscribe to the channel. If you have any questions about anything that I attempt to explain during this video, please put your questions in the comment section. All right. Or if you just have comments, put your comment in the comment section. And also, last but not least, please share this video with at least one other person. All right. So as you see, I have my Clark Atlanta sweatshirt on. I always like to promote historically black colleges and universities. When Clark Atlanta, before Clark College merged with Atlanta University, W.E.B. Du Bois used to be a professor at Atlanta University. I just wanted to point that out in case you didn't know. But if you did know, cool. I just reminded you of something that you already know. All right. So what are we doing today? We are comparing fractions, right? We are comparing fractions. This is an important skill for young people to have, elementary school age students. If they may start working with fractions in the third grade, hopefully before the third grade, but in third grade or fourth grade, they should know how to compare fractions, meaning you should know how to tell if you're given two fractions or even three or four fractions, which fraction is the biggest, which fraction is the smallest, or if the fractions are equivalent, meaning they have the same value. Because two fractions can have different numerators and denominators and still have the same value. For example, 3/4 is equivalent to 9/12, right? 3 and 4 are different from 9 and 12. They're different numbers. But the relationship between the numerator, the top number, and the denominator, the bottom number, are the same. 3 out of 4 is equal to 9 out of 12. If you take a quiz and there are 4 questions and you get 3 correct, that means you've earned a 75%. If you take a quiz and there were 12 questions and you get 9 correct, you still earned a 75%. That's proof that 3/4 and 9/12 have the same value. All right, value. The numbers are different, but the value is the same. All right, and there are a lot of examples like that. Literally an infinite number of examples like that in the real number system. Now, we got two fractions up here. We got 7/9 and 8/11. And what we're going to do is, or what I'm going to do is, I'm going to show you 3 different methods that you can use to compare fractions. The first of which I call the Malcolm X method. Now, why do I call it the Malcolm X method? Because we're essentially using something called the cross product property. We're going to go in an X formation. We're going to multiply the numbers that are diagonal from each other, the 7 and the 11, and then the 8 and the 9, right? We're going to multiply those. So in order to do this, right, and then in order to do a lot of things that I show here on this channel, it is required that you understand multiplication. It is even better if you have the multiplication facts memorized, because then this stuff goes real quick, right? If you don't have the multiplication facts memorized, I suggest you print out a multiplication table or go get a black composition notebook, one of the marble ones from back in the day, right? With the multiplication table on the inside back flap, so you can look at it, so you can see. All right, that'll also help you to memorize the multiplication facts from using the table. All right, it's very helpful just to have the multiplication facts memorized. When you get to algebra, it'll be helpful. Algebra 1, algebra 2, geometry, pre-calculus, trigonometry. It's just very helpful, right? And a lot of things we do with arithmetic, such as this, but also in the successively higher levels, you got to know your multiplication facts. And ain't no way around it. It don't matter. And it don't matter if you can put it in a calculator. It don't matter. You shouldn't need to use a calculator for everything. Just memorize your multiplication facts. Just do it. All right? Like Nike, just do it. All right. Now, let's go ahead. Malcolm X method, right? Because I like to evoke the names of ancestors, right? We're in 2025 right now. This year, we actually in May. This month is the 100th anniversary of the birth of Omowale Malcolm X. Omowale was the name he got when he took a pilgrimage to Africa, right? He spent a lot of time in Africa the year before he made his transition and was assassinated, right? So in 1964, he's making moves all around Africa. People in Nigeria renamed him. They gave him the name Omowale. Omowale, which means the sun has returned. That's what Omowale means. The sun has returned. They gave him that name. So some people know him as Omowale Malcolm X. All right. So let's do 7 times 11. 7 times 11 is 77. When you get that product, you write it above the numerator that you just multiplied. The numerator, not the denominator. Denominator is the bottom number. Numerator is the top number. We did 11 times 7 or 7 times 11, however way you did it. But 7 is the numerator. So you're going to write 77 above the 7. All right. Boom, do that. And then we go the other direction. 9 times 8. 9 times 8. 9 times 8 is, again, multiplication facts. Know your multiplication facts. 9 times 8 is 72. 9 times 8 is 72, so you're going to put the 72 up here. All right, now, what you do is you look at those two products. We got 77 and we got 72. Ask yourself, which number is bigger? 77 is bigger. Right, 77 is bigger. Since 77 is bigger, that means that the fraction that 77 is written above is the bigger fraction. It's going to work every time. All right. So now we also have to know how to write our greater than or less than signs. We're not going to use the equal sign because 77 is not equal to 72. 77 is greater than 72. With the greater than sign, the open part faces the bigger value, the open part. So we write it like this. Boom. Sideways V. Sideways V, open part faces the bigger value. Since 77 is written above 7/9, notice I said 7/9. I ain't say 7/9. It's 7/9. 7/9, right? The denominator is 9. So that means we took an object, we divided it up into 9 equal parts. 9 equal parts. The numerator is 7. That means we focused on 7 of those 9 parts. We only focused on 7 of them, right? The other 2, we don't care about. The other 2 parts, why did I say the other 2? Because 9, there are 9 equal parts altogether. That means we could focus on all 9 of them. If we focus on all 9 of them, then that means we focused on everything, the whole thing, right? But we only focused on 7 of the 9, right? There are 9 altogether. We only focused on 7 of them. So it's 2 parts that we don't care about. All right, we don't care about those 2. Over here, we got 8/11. We took another object, cut it up into 11 equal parts. Of course, those parts are going to be smaller than these because 9 parts is less parts than 11. So if you got to make more parts, that means each part is going to be smaller. Each part is going to be smaller because you got more parts, right? So we got 11 equal parts. We're focused on 8 of them. We care about 8 of those 11 parts. That's what 8/11 means. All right, that's the Malcolm X method. Next method is called decimal conversion. And you know what? Let me go grab my calculator real quick. Hold that thought. So as I grab my calculator, my trusty Texas Instruments scientific calculator, boom, here we go. All right. So we got 7/9. So also understand that a fraction is just a representation of a division problem. We're dividing the numerator by the denominator. That's what it's telling us to do, right? Also, 7 divided by 9 equals. Now, this gives me a repeating decimal, a bunch of 7s. So I'm going to round it off to 0.78. Now, why did I round it off to 8? Because it's a bunch of 7s. So I'm in the third position, right? The third decimal place. Tenths, hundred, in the thousandth place, there's a 7. That means that the 7 that used to be right here got rounded up and turned into an 8. So we got 0.78, right? Now I'm going to do the same thing for 8/11. 8/11. 8 divided by 11. 8 divided by 11, right? We go top down, not bottom up, top down. Top down, we follow gravity, right? I take this marker, I drop it, boom, it goes down. It don't float up in the air, right? We do the same thing with division. Top divided by bottom. 8 divided by 11. 0.72, 72, 72, 72, 72, right? I round that off to 0.73 because in the third decimal place, we got a 7, which means that this used to be a 2, but because there was a 7 right here, that makes the 2 go up, get rounded up and turn into a 3. So 0.73. So now I can compare these two-digit decimals, right? Think about money in the store, right? 78 cents, 73 cents. Which one is bigger? 78 cents is more than 73 cents. Therefore, that's another way to know that 7/9 is equivalent. I'm sorry, not equivalent. 7/9 is still greater than 8/11. Because if 78 cent is greater than 73 cent, and 78 cent is equivalent to 7/9, and 73 cent is equivalent to 8/11, that means that 7/9 must be greater than 8/11 because 78 cent is greater than 73 cent. All right, so that's method number 2, using the decimal conversion method. Now, last but not least, we're gonna use the LCD. LCD stands for least common denominator, and that's something that we're gonna use whenever you have to add or subtract fractions. Whenever you have to add or subtract fractions, you need to find a least common denominator between the two fractions, right? So that way you're not adding apples and oranges. Now, when you want to divide fractions, you could use a least common denominator, but you don't need to. When you want to multiply fractions, you could use a least common denominator, but you don't need to. But you definitely need to whenever you're adding or subtracting fractions. You must have a common denominator, right? The denominator is the number at the bottom, right? Like right now, we can't add ninths and elevenths. Those are two different things. We can't add ninths and elevenths, right? That's like adding apples and oranges, right? Apples and oranges, ninths and elevenths. You know, they're two different things. We can add ninths and ninths, this many ninths plus this many ninths, or we could add elevenths and elevenths, right? This many elevenths plus this many elevenths. We could do that, but we can't add ninths to elevenths, right? Again, it's like adding apples and oranges. If you have 3 apples and 2 oranges, you don't have 5 oranges altogether. You don't have 5 apples altogether because you don't have a common denominator. Now you could say the common denominator is that they're all fruit. So you can say, well, we have 5 pieces of fruit, right? Because we got 3 apples and 2 oranges. We have 3 pieces of fruit and 2 pieces of fruit. We can look at it like that. That's 5 pieces of fruit altogether. But you can't add apples and oranges and get a total number of apples, right? So we create something called a least common denominator, right? Denominator, right? What does that mean? That means what is the smallest number? Least means smallest. Least means smallest. Least means smallest. What is the smallest number that each of these numbers can both multiply into, right? Both of them that they have in common. What do they have in common? It's like if you go to a school and there's a uniform policy, everybody wears the same uniform, right? That's what y'all have in common, right? Or if there's no uniform policy, well, everybody got shoes on, probably. Or maybe some people have the same type of shoes, same type of sneakers, right? People got a lot of people got Nike. Some people got New Balance on. Some people got Pumas on. Some people got Adidas on, right? So that would be something people have in common, right? We're looking for a number that 9 and 11 can both multiply into. And 9 and 11 have in common. Now, I'm gonna tell you a shortcut. Sometimes, in order to find the common denominator, you just multiply the numerators by each other. I'm sorry, denominators, not numerators, not numerators, not numerators. Multiply the denominators by each other. So 9 times 11 will give us 99. In this particular case, 99 is the common denominator. How do I know that? Because if I started multiplying 11 by 1, then by 2, then by 3, then by 4, then by 5, then by 6, then by 7, then by 8, then by 9, 99 is going to be the first number that 9 also multiplies into. Watch this. What's 11 times 1? 11, right? Can I multiply 9 by a whole number and get 11? And again, this is why you need to have the multiplication facts memorized. If you have the multiplication facts memorized, finding an LCD becomes very easy. So do yourself a favor. As soon as possible, memorize the multiplication facts. Now, back to what I was saying. If I do 11 times 1, that's 11. 11 can multiply into 11 itself. Can 9 multiply into 11 evenly? No, it can't. 9 times a decimal will give you 11. Now, what's 11 times 2? 22. 22 is a multiple of 11. Is 22 a multiple of 9? No, because you can't do 9 times any whole number to get 22. 9 times 2 is 18. 9 times 3 is 27. So 22 is not a multiple of 9. What about 11 times 3? That's 33. Is 33 a multiple of 9? No, because 9 times 3 is 27 and 9 times 4 is 36. All right, are you starting to see the pattern here? What's 11 times 4? 11 times 4 is 44. 44. Can I multiply 9 by a whole number and get 44? No, I can't. So that means that 44 is not a multiple of 9. It's only a multiple of 11. The C in LCD means common. What do they have in common? What do they share? What is the number? What is a number that they both can multiply into? Not that just one of them can multiply into. Sure, 11 can multiply into 44, but 9 can't multiply into 44. Not by another whole number, not evenly, right? What if we stop multiplying 11s? What if we started multiplying 9s? 9 times 1 is 9. Can 11 multiply into 9? No, it can't. What's 9 times 2? 18. Can 11 multiply into 18? No, it can't. 11 times the decimal will give you 18. But we're not dealing with decimals right now to find a common denominator. What's 9 times 3? 27. Can 11 multiply into 27? No, it can't. So 27 is not a common multiple. What's 9 times 4? 36. Can 11 multiply into 36 evenly with nothing left over? No, it can't. You would need to multiply 11 by a decimal to get 36. And we're not multiplying by decimals. We're only multiplying by whole numbers. That's why 99 is the common denominator. You know why? Because 11 times 9 is 99. And 9 times 11 is 99. So you see how it's like a meeting point. The LCD is like a meeting point, right? Where do they meet up at? What number does a 9 and 11 meet up at? What's the meeting point? It's 99, right? And what's the closest meeting point? 99, right? Now, of course, there are bigger numbers that they also meet up at, but that's not the least. The L in LCD stands for the least. What's the least common denominator? What's the smallest number where they both can meet up at, right? Like two people trying to meet up to go somewhere. All right. So what we're going to do is we're going to create equivalent fractions that have the denominator of 99. So we're going to do this. This 7/9 is going to turn into a fraction with 99 for the denominator. Draw another box. This 8/11 is going to turn into another fraction with the denominator of 99, right? Now, If this 9 turned into a 99, what do you think this 7 is going to turn into? Ask yourself, how did I make 9 turn into 99? Right? I multiplied by 11 because 9 times 11 is 99. Now, whatever I do at the bottom is what I do up top. Whatever I do down the bottom is what I'm going to do up top. So if I multiply by 11 down bottom, I'm multiplying by 11 up top. Again, you got to know your multiplication facts. This is going to be so easy if you know your multiplication facts. I promise you. What's 7 times 11? 77. So 7/9 is equivalent to, meaning it has the same value as 77 99ths. So this is like saying you take an object, cut it up into 99 equal pieces, and then we focus on 77 of those pieces. That's what this fraction means. Now, 11. We need an equivalent fraction. 11 turned into 99. How? By multiplying by 9. So if I multiply 11 by 9 to get 99, what do you think I'm going to do with this 8? What do you think I'm going to do with this 8? If I multiply by 9 on the bottom, I multiply by 9 on the top. What's 8 times 9? 72. Again, you got to know your multiplication facts. I can't stress that enough. Now we got 77 99ths compared to 72 99ths. All right, 77 99ths compared to 72 99ths. Now, how many 99ths do we have? I got 77 right here, and I got 72 right here. And look at the coincidence. Remember when we used the Malcolm X method from the beginning? Shout out to the ancestor, Omowale Malcolm X, 100th birthday, May 19th, 2025, right? Didn't we do 11 times 7 and get 77? Then we do 9 times 8 and get 72. See how that works? It's always going to work out like that. All these methods are connected to each other. All these methods are connected to each other. So 77 of these is more than 72 of these. That means that this is still 77 99ths is bigger than 72 99ths. And that's how you use an LCD to compare fractions. All right, so we went over the 3 methods. The Malcolm X method. Some people call it the cross product property or the butterfly method. A lot of teachers, they're not as familiar with Malcolm X, or they don't want to mix math with history. That's cool. That's on them. That's their loss. And unfortunately, the loss of the students that don't get to get the history lesson at the same time. That's what hystematics is all about. Why not just get both at the same time? But anyway, the decimal conversion, all right, and also finding the LCD. There's another method where we find common numerators, which is cool. I'm gonna do some other videos on that, specifically on that method. I like that method too. Those are the 4 methods altogether. These 3 plus finding common numerators that I teach to my students at Cheney. My education majors that are studying to become teachers, right? So I'm gonna do some separate videos on finding using the common numerators. All right. So like I said earlier, make sure you subscribed if you're not already. Hit the like button if you didn't already. If you join the video late or whatever. If you got questions about anything we did, please put your questions in the comments. Put your questions down in the comments so I can see them. I might make another video just for you addressing your question. And also share this video with at least one other person. All right. And again, shout out to Clark Atlanta University down in the AUC. All right. Peace.